For the conjugate acid, they'll draw NaOH₂+. Hey there, OChem Ninjas. This video is just a quick public service announcement that gets to one of my biggest pet peeves as an instructor, and it refers to the fact that sodium doesn't make covalent bonds. Sodium doesn't make covalent bonds. Pretty much nothing on the left side of the periodic table makes covalent bonds. So when you see anything like sodium or potassium or anything over on that left side of the periodic table, you need to remember that sodium doesn't make covalent bonds. Sodium is cationic. In solution, this will fully dissociate into sodium plus and oxygen minus. I think it's a good idea to even explicitly write the plus and the minus so that you remember that sodium does not make covalent bonds. Furthermore, when you draw the arrows for this reaction and you have the oxygen attack the carbon and kick out the chlorine, you should not have another arrow showing the sodium leaving. Sodium doesn't make covalent bonds. There's no covalent bond here to be broken. This would imply that sodium is leaving with a lone pair of electrons. Sodium will never have a lone pair of electrons, not in this course. So we don't need an arrow here because there's no bond to be broken. It would be inappropriate and incorrect to show an arrow going to sodium. Let me show you a few other places where this comes into play. I've seen students look at this reaction and call it an SN1 reaction because oxygen doesn't have a negative charge as drawn. You may not have gotten to SN1 and SN2 reactions yet, and that's okay. But looking at this molecule, you have to know in your head that sodium does not make a covalent bond. When you dissolve it in solution, sodium will dissociate, methoxide will dissociate. Sodium will dissociate with a full positive charge. Methoxide will dissociate with a full negative charge. Sodium methoxide is a good, strong anionic nucleophile. Sometimes we omit the sodium and just write OMe-. Sometimes we write sodium plus and OMe-, but sometimes we just type the letters NaOMe. But we have to know that sodium does not make covalent bonds. This is a fully ionic molecule, oxygen has a negative charge, and is a very good, strong anionic nucleophile, and we'll do an SN2 reaction to form the SN2 product. Or in a situation like this, I'll see students who want to draw in the lone pairs on the nucleophilic atom, and I firmly support that decision. I think it's a fantastic idea to draw in lone pairs if you need to, but I'll see them draw in 2 lone pairs on oxygen. Here we have potassium, not sodium, but potassium doesn't make covalent bonds either. There's not a covalent bond between oxygen and potassium. There's a third lone pair on oxygen. Potassium doesn't make covalent bonds either. Potassium is fully cationic and oxygen is fully anionic. Even if they get the product correct with the non-Zaitsev alkene, we still need to know that potassium does not make covalent bonds. Finally, in an acid-base reaction, if we use sodium hydroxide as our base, students will draw the arrows correctly. Sodium hydroxide attacks the acidic hydrogen, kicks out Cl-, and then for the conjugate acid, they'll draw NaOH₂+. Friends, sodium doesn't make covalent bonds. Sodium hydroxide is fully dissociated as sodium plus and oxygen minus. The conjugate acid is not NaOH₂+. The conjugate acid is water, and we have sodium cation, which can associate with Cl- anion to form NaCl. Friends, as you mature in your OChemNinja journey, one of the things that you need to be able to do is see a countercation like sodium, potassium, lithium, calcium, anything over on that left side of the periodic table, and know that it is dissociated as a full cation. Sodium does not make covalent bonds.
I'm glad you're here with us for this training today. Check out these other videos in my playlists to see if there's anything else that can help you level up your ninja levels even further. As always, don't forget to like and subscribe.